Hey, this is Mrs. Pagano. I'm going to be walking through some of these notes with you to review what we did last week in week 12. First, we're going to be looking at systems of equations, and the ways that we have learned how to solve so far are by graphing, substitution, and equal values. And so those are the ones that we're going to be practicing. First, we're going to look at solve by graphing. The way that we know how to graph most easily is in the slope-intercept form. So we're looking at y equals mx plus b, and these are both in that format. So we know that any graph that we want to begin, we're going to start with x equals 0. So if you start by plugging in x equals 0 into either of these equations, you will get 0 and then minus 3, which means that our beginning point is at -3. So I'm going to begin at -3 on the y-axis because it is going to be a y equals -3 when we plug in 0. -3 is down here. I can even label it so that I know why I stuck that dot there. And then I need to know how steep this line is, so I'm looking for a slope. And the slope of this line here is actually 1 because we are looking at a 1x. So I'm going to take a slope of 1 and make it a change in y over change in x by making it a fraction, 1 over 1. And so I'm going to go up 1 and over 1. Up 1 and over 1. And I'm going to repeat that. Up 1 and over 1. Up 1 and over 1. I'm going to just keep repeating it until I hit the edge of the graph, and I'm going to go backwards. So instead of going up and to the right, I'm going to go down, down 1, and left 1. And so down 1 and left 1 puts me here. Down and left puts me here. And so I have a line here that I can connect the dots on. Remember, we are connecting the dots of the crosshairs and not the dots that I drew. Notice I'm trying to go exactly through the crosshairs on the graph because this dot right here was huge. So I'm going to get rid of it and draw a little bit better one on that small. Okay, so I could keep adjusting my line, but we kind of have the idea here. Okay, so the next line I want to graph is this line right here. It's helpful if you use two colors and identify which one you're graphing. So if I plug in x equals 0, 0 times anything is 0, so this ends up dropping out. And we're left with y equals -1, which means my beginning point is at -1. So I'm going to go on the graph down to -1, place my beginning point. Next, I need a slope. My slope is actually -1 here. Now, if my positive slope was going up to the right, my negative slope is going to go down to the right. So instead of going uphill, I'm going downhill. So I have a slope now of -1, which as a fraction is -1 over 1. So remember that this is change in y over change in x. And so if it's negative, I'm going down, and if it's positive, I'm going to the right. So I'm going to go down 1, and I'm going to go over 1. And you can see I've already hit the other line. I already found the intersection point. I could continue to go down 1 and over 1, down 1 and over 1, and find all of these points. But at this point, it's not really necessary because I already found the spot where they intersect, which is right here. And the goal is to know at what coordinate, that's what we have down here, at what coordinate do the two lines intersect? Well, when x is 1 and y, I guess I could put it down here, is -2. Okay, so I was saying when x is 1 and y is -2 is the intersection point of those two lines. Now, if we had context, we could say what x equals 1 represents, whether it's 1 hour, we lose $2 because of spending money on food or something like that. But we don't have any context here. We're just trying to practice the idea of where do they intersect. Okay? We also wouldn't necessarily solve a lot of problems by graphing, but what we do want to be able to do is look at a graph and understand that that intersection point has meaning, and before that intersection point, one line is greater than the other, and after that intersection point, one line is less than the other. So you can notice that the blue line before and after this point right here, that the blue line is higher than the green line, and after the intersection point, the blue line is less than the green line. And so we can just kind of see that this intersection point is definitely showing us something. All right, moving on to substitution. For substitution, we are looking for a value that we have an expression for. So in both of these cases, we have y equals, and so I can say y equals x plus 3. If I know that the value of y has a relationship of take the value of x and add 3 and you'll have y, then I can substitute that in to the other equation. And the reason I want to do that is because I have two variables, and I can't solve for both variables until I eliminate one of them and solve for one variable. So when I plug in x equals 3 into y, saying instead of y, I'm going to write x equals 3, I can rewrite it like this. X plus 3 is now equal to 2x plus 4. Now you can see I don't have a y in my equation, and now I can solve for x. So I'm going to identify where my x pieces are, and I want to move them to one side. Your choice. I like to move the smaller so that it stays positive if possible. X minus x is 0. Keep the 3. 2x minus 1x is just 1x, or x, and plus 4. So you could ask yourself what plus 4 equals 3, but that might be hard with negatives. So you just take the opposite. If I remove 4 from both sides, 4 minus 4 is 0. Keep the x, and 3 minus 4 is actually negative 1. So the value of x in this system is negative 1. So I can go ahead and place it here, and I still need to know what y is, because remember, we're looking at two lines that intersect, right? So that's the graphical view of it. And so if you're looking at it with algebra, you're like, okay, I found x, now I need to find y. Well, that's pretty simple. You can take either one of these equations. I like this one because it's pretty simple. And I can say the y value was equal to whatever x is plus 3. So we just found that x has to be negative 1. And so negative 1 plus 3 means y must be 2. And so we can see the intersection point for these two lines are negative 1 and 2. And again, that context means that this is when the two equations are the same. Now you can definitely test your answer by plugging it back in. You can plug in x equals negative 1 and y equals 2. We pretty much did that here, but you could do it into both equations to verify that you are correct. The next one is the equal values method, and in the equal values method, it's really similar to substitution, but often we are talking about a situation where we have an equation for two different companies or an equation for 2 different days of sales, and what we want to know is when are they the same. So basically, if this was like company A and company B, which this doesn't necessarily represent companies, but if we had company A and company B and we wanted to know when is company A equal to company B, then we would say, oh, well, company A is negative 2x plus 5 and company B is 2x plus 1. And when are they the same? That's what we want to know. So that's the equal values method. So when they're both set equal to y, you're like, well, this is total cost and this is total cost. So I want to know when this total cost equals this total cost is basically what we just did. So now we can solve the same way that we did substitution by adding the x's to one side of the equation. So I like to move the smaller. Since this is negative, it's smaller than this one. This adds to 0. 5 equals 4x plus 1. I want to get x by itself, and x is being multiplied by 4 and added by 1. So I'm going to remove the addition first because this is technically attached. So we're going to minus 1 first. I get 4x is now equal to 4. Again, it's multiplication. The opposite of multiplication is division. So we have x equals 1. When x equals 1, what does y equal? I can go back up to either equation and find out that answer. So I'm going to take this equation right here and say that y is equal to twice x plus 1, and we know that x is 1. So I'm going to substitute x equals 1, that's what we found here, and we're plugging it in right there. So when we simplify, we get 2 times 1 is 2, plus 1 means that y equals 3. So when x is 1 and y is 3 is when these two linear equations have equal values. Next, we have how do we check and see if a point is a solution to the system? Now, we can do this graphically with Desmos, or we can do it algebraically. So I want you to see, using Desmos, that I've put these two equations in, and where they actually cross right here is decimals. And most of the equations that we solve in life don't come out to perfect whole numbers. We do that so that you can feel confident that you found the answer. But this one, the solution is not pretty, not easy to calculate. And we can see that the point 2, 1, the green point, is definitely not the intersection point. So we're going to go back to our notes here and say, how do I show this algebraically? So I know that this is a coordinate, xy, and I'm asking if it satisfies both equations. I'm asking, is that line, are these two lines going to go through the point 2, -1? And we know they're not from the visual. So what we're going to do is test it on each. So I'm going to take x minus 2y equals 4, and I'm going to test the point, and I'm going to take 3x plus y equals 6, and I'm going to test the point. And so we take the coordinates for x and for y, and we're going to plug them in, and then we're going to take the coordinates for x and y and plug them in. So if x is 2 and y is -1, we're asking if this satisfies the equation. And it shouldn't, because the point wasn't on either line. So this is not 2 minus 2. This is like 2 minus this that's being multiplied, okay? So just be careful with your operations. This is 2 minus, remember we multiply first, so 2 times -1 is -2. So I put brackets to kind of help myself do one operation at a time. And then if I'm taking the opposite, right, I'm subtracting -2, I'm taking away the negative, so it becomes plus 2. And it says 2 plus 2 equals 4. Yep, 2 plus 2 equals 4. Okay, so was it actually on that line? It doesn't show that it was. So we have to double check and make sure that we did something correctly here. So 2, -2, -2 minus... Well, I don't see my error, but I'm going to go back and check that in just a minute. So we'll do the same thing on the same one. 3 times x is 2 plus y is -1 equals 6. So we get 6 plus -1 is -1 equals 6. No, 6 take away 1 is 5. 5 does not equal 6. Since it doesn't satisfy this equation, we know that it's false. And since the point is not on both lines, then it is not the solution of the system. It is not the place where the two lines cross. Now, I'm going back to this one here and deciding that maybe I messed myself up here with my brackets. So let's try again. So this is saying 2 minus 2 times -1. I want to do this operation first. So -2 times -1 is +2. I'm still getting +4. And my graph is still not showing that 2 -1 is on that line. 2 minus 2y, 3x plus y. The equations are matching. Ah, I see what my problem was. This dot right here says 2, 1, and the question was, is 2 -1 a solution to the system? So Let me change this to -1. And we can see that it actually is a point on the line. Now, I could redo this video so that you don't see my mistake, but what I want you to see is that when you make an error or something doesn't quite line up, that you can go back and figure it out. Okay? So now I'm seeing that it should lie on the line, and 2 plus 2 is 4, and this is true. We did see that 2 negative 1 was actually on the line. Just one more time. 2 negative 1 is actually on that first line. All right, so last problem to do together. Juan Carlos wants to join CrossFit membership. Top CrossFit has an $80 joining fee and cost $40 per month. Hillsdale CrossFit has no joining fee and costs $50 a month. Okay, so if we have Top CrossFit at $80 a month, we can say that the total cost of the CrossFit is going to be $80 plus $40, and we don't do it $40 once, but per month. And so we have to give a variable of how many months is going to be represented. Now, I could use M for months, but to help us put it on a graph, it helps us if we use X and Y. Once I write an equation, I need to be able to tell someone else what X and what Y are going to represent. So we're going to say let X equal the number of months and let Y equal the total cost. Okay, when I'm reading this scenario, I'm asking myself, what are the unknowns? I don't know how much it's going to cost because it depends on how many months I subscribe to this gym. I don't know how many months yet until I decide how much is 1 month, how much is 5 months, how much is a year. Okay, and so those are the two unknowns, and the total cost depends on the number of months that we spent. So this is how we call this the dependent variable. Okay, X is the independent variable because it doesn't matter. It doesn't matter or depend on anything else. I get to choose the number of months. So for the Hillsdale CrossFit, I can write an equation of the total cost having no joining fee and costing $50 per X number of months. Now I don't need that 0, so I could rewrite this as just Y equals 50X, and that would be just fine. We can solve this by substitution. We could solve this by equal values. They're pretty much set up the same way. And so I'm going to just say if Hillsdale CrossFit costs $50 a month, that is equal to Y, or the total cost. And so what I'm asking is, I can just replace this Y with 50X. What I'm asking is really, when does Hillsdale at $50 a month equal Top CrossFit at $40 a month plus $80? Okay, so one has a more expensive monthly fee, but no startup fee. So when we solve, we can say minus 40X. So what's the difference in the two fitness memberships per month? Well, the difference in their monthly cost is $10 a month. Okay, so now I'm asking, when does $10 a month end up equaling $80? Because I'm going to save $10 a month here, right? I'm going to save $10 a month with Top CrossFit, but I've got this $80 join fee, so that kind of adds up there. So what we're looking at is how many months does that catch up? So when we divide by $10 a month, we say at 8 months, right? 80 divided by 10 is like divide by 10, you get 8. 8 months is when they will cost the same, when X is 8 months. What is that cost? Okay, so we need to make sure that we understand that this is X equals 8 months. What is the cost? That means what's the Y value? So at 8 months, I can go back in here and say, if I know X is 8, I can substitute here and I'll be able to find out how much it'll cost me. So Y is equal to 50 times 8, and 50 times 8 is 400, and then we have to understand that this is $400, right? Because we're talking about total cost in dollars. So you should be able to write a sentence at the end to say that at 8 months, both memberships will cost $400. And that's how I would like you to end your notes here, is by writing that statement, and your teachers can look for that statement of understanding what this whole scenario means. Thank you.